Hi everyone, hope you all are good. We are here for grade 10 math. So we are working on the book Principles of Mathematics grade 10. Lesson we are working on is applying quadratic models, and the lessons we're going to cover from the chapter is solving problems using quadratic relations, connecting standard and vertex form. So here it is, solving problems using quadratic relations. All quadratic relations can be expressed in vertex and standard form. Quadratic relations that have zeros can also be expressed in factored form. For any parabola, the value of a is same in all three forms of the quadratic and all three forms of the equations of quadratic relation, right? Okay, let's just start with the practice questions. Okay, use the given information to determine the equation of each quadratic relation. In vertex form, y equals a times x minus h whole square plus k. Question number 1. You are given a equals to, okay, you have to write in vertex form, that would be y equals a x minus h whole square plus k, right? A equal 2 and vertex equals 0, 3. Okay, just replace the value in the equations, right? A equals 2, here you have a, that would be y equals to x, h and k, right? So it would be x minus 0 whole square and plus 3, so it would be 2x square plus 3, right? Okay, the next one is a equals 0.5 and vertex equal negative 3.5 and 18.3. A equals 3.5 and vertex equals, a equals 0.5 and vertex equal negative 3.5 and 18. Okay, vertex equals negative 3.5 and 18 and a equals 0.5, right? So the equation in the vertex form would be y equals a times x minus h whole square plus k. So it would be a is 0.5, x minus, it would be x plus 3.5 whole square and plus 18. That would be the equation, right? Okay, let's just start with question number 2. Question number 3. The arc of the bridge in the photograph can be modeled by a parabola. Determine the equation of the parabola. On the upper part of the bridge, three congruent arcs are visible in the first and second quadrants. What can you conclude about the value of A in the equations of the parabolas that model these arcs? Right? Okay, determine the equation of parabola. So you have to determine the, you can see the vertex of the parabola is 0, 0, right? So it would be y equals ax square. Equation would be y equals ax square because the vertex is 0, 0, right? Vertex is 0, 0, so equation would be y equals ax square. So let's just select any point on the parabola. It would be -1 and -4, right? You have a point -4 and -1, right, on the parabola. Just put the point in equation and calculate the value of a. It would be y is -1 equals a times -4 square. That would be a times 16 equals 1. So a equals 1 over 16. So the equation would be y equals 1 over 16 x square, right? Okay, let's just start with question number 3. Determine the equation of quadratic relation in vertex form given the following information. Vertex and passes through the point. Okay. Okay, so my questions. Okay, vertex at 0, 3, 0 0.2, -5. Vertex at, okay. So the equation would be y equals a times x minus 0 square plus 3. You can put this point and calculate the value of a, right? It would be y equals a x square plus 3. Just put this point. Y is -5. That would be -5, -3 equals a 4. That would be -8 equals 4a. A equals -2, right? That means the equation is y equals -2x square plus 3, right? That is the equation of the parabola, right? Okay, let's just start with question number 5. Determine the equation of each parabola in the vertex form, right? Okay, just look at this parabola. You are given the vertex that is -1 and -4, right? And a point 1, 0. Just use the vertex and the point. Vertex is -1 and -4, and point is 1, 0, right? -1 and -4. So the equation is y equals a times x plus 1 whole square minus 4, right? Now just put the point y is 0. So a equals 2, right? Just put the point in the equation back. So it would be y equals 2 times x plus 1 whole square and minus 4, right? Okay, you can do the rest of the parts by yourself. Okay, let's start with question number 7. A quadratic relation has zeros at -2 and 8 and a y-intercept of 8. Write an equation of the relation in the vertex form. So you are given zeros, right? They are -2 and 8. You are given zeros. right? They are negative 2 and 8. And y-intercept, that is 8. Okay, so the equation would be y equals x plus 2 and x minus 8, right? That would be the equation in factored form, right? Y equals a times x plus 2 and x minus 8, right? Use the y-intercept 8. 8 equals a, 0 plus 2, 0 minus 8. That would be a 2, 8 equals negative 16a. So a equals 8 divided by negative 16, that would be a equals negative 1 over 2. So the equation is y equals negative 0.5 times x minus 8 and x plus 2, right? So you can write the equation in the, you can see the zeros 8 and negative 2, right? The midpoint is 8 minus 3 is 2 is 6, 6 over 2 is 3. That means you have to calculate the vertex. We have the axis of symmetry x equals 3, right? Just put x equals 3 in the equation. Y equals negative 0.5, 3 minus 8 and 3 plus 2. That would be 3 minus 8. Negative 0.5 minus 5, 3 plus 2 is 5. So it would be 5 times 5 is 25 and that would be 12.5. So the equation is y equals negative 0.5 x minus 3 whole square and plus 12.5. That would be the equation of the parabola, right? Okay, let's start with question number 9. Express each equation in standard form and factored form. The first one is y equals x minus 4 whole square minus 1. You have to write down the equation in standard form and factored form, right? Just solve this one. Y equals x minus 4 whole square is x square plus 16 minus 8x minus 1, right? Just open the square using square formula, right? It would be x square minus 8x, 16 minus 1 is 15. Okay, let's just make the factors. Negative 8 and 15. Find two numbers when multiplied makes 15. When added or subtracted makes negative 8, right? So 5 times 3 is 15. Negative 5 and negative 3. It would be x square minus 5x minus 3x and plus 15. So you have x common x minus 5. You have negative 3 common x minus 5, right? So it would be x minus 3 and x minus 5. So here is the equation in factored form, y equals x minus 3, and here is the equation in y equals x square plus 15 is the standard form, and that would be the factored form, right? Okay, let's start with question number 12. The graph of y equals negative 2x plus 5 whole square plus 8 is translated so that its new zeros are negative 4 and 2. Determine the translations that was applied to the original graph, right? You are given the x-intercepts are new zeros are negative 4 and 2, right? So with the new zeros, the new equation would be y equals negative 2, x minus 2 and x plus 4, right? The axis of symmetry would be negative 4 plus 2 divided by 2, that would be negative 1, right? That is the axis of symmetry. So you have to calculate the new vertex, right? Just use x equals negative 1 to calculate the new vertex, right? Just replace the x with 1. So it would be y equals negative 2, 1 minus 2, 1 plus 4. That would be negative 2, negative 1, and 4 plus 1, 5. That would be 5 times 2, 10. That means y equals 10. No, that is negative 1, sorry. It would be negative 3 and 4 minus 1 is 3. So it would be negative 9, 9 times 2 is 18. So y equals 18, right? So the new coordinates of both the vertices to determine the translation is moving from negative 5 to 8. The original is negative 5 in the question, right? And the new one is negative 1 and 18. That means that is a translation of 4 unit right and 10 unit up. Okay, let's start with question number 17. A parabola has a y-intercept of negative 4 and passes through the point negative 2 and 8 and 1 negative 1. Determine the vertex of the parabola. So the parabola is symmetrical, right? So let's just start determining the equation of axis of symmetry. The y-intercept of negative 4 and passes through the point negative 2 and 8. That means the y values go down from 8 to negative 4 and back up to negative 1. So the equation would be y equals 3x square minus 4, right? Okay, question number 19 is the equation of the parabola is y equals a times x minus 1 whole square plus q, and the points are negative 1, 9 and 1, 1 lie on the parabola. Determine the maximum value of y. You can see the parabola is in the vertex form, right? From the equation. And the axis of symmetry is x equals 1, right? So because axis of symmetry is 1, so there is a point 1, 1, right? That means the maximum value of y is 1. When axis of symmetry is 1, the value is 1. That means the maximum value of y is 1. Right? You can see from here, this one is the axis of symmetry, right? And you can see when x is 1, y is 1. That means the value of the y is 1. Okay, we are done with the lesson. Let's just start with the next lesson. The next lesson is, okay, here it is. Connecting standards and vertex form. Right, let's just start with the lesson, that is connecting standard and vertex forms. If a quadratic relation is in standard form and cannot be factored fully, you can use partial factoring to help you determine the axis of symmetry of the parabola. Then you can use the axis of symmetry to determine the coordinates of the vertex, right? Okay. Okay, let's start with practice question, question number 4. A parabola passes through the points 3, 0, 7, 0, and 9, negative 24. Determine the equation of axis of symmetry. Determine the coordinates of the vertex and write the equation in vertex form. Write the equation in standard form. Okay. The points are 3, 0, 7, 0, 9, negative 24. And 9, negative 24. So you have to calculate equation of axis of symmetry, coordinates of vertex, and write equation in vertex form, right? So the axis of symmetry would be 7 plus 3 over 2, right? That would be 5. So the equation of axis of symmetry is x equals 5. Okay, then you have to calculate the vertex. So you can write the equation in factored form, that would be y equals a times x minus 3 and x minus 7, right? Because 3 and 7s are the x-intercepts, right? Let's just use the point 9, negative 4 and 24 and calculate the value of a. It would be negative 24 equals a, 9 minus 3, 9 minus 7. That would be negative 24 equals a, 2 and 9 minus 7 is 2. 9 minus 3 is 6. So it would be negative 24 equals a 12. 12a equals negative 2. So the equation is just replace 2 here. Y equals 2 times x minus 3 and x minus 7, right? So we already have axis of symmetry, that is 5. Replace x with 5. 2, 5 minus 3, 5 minus 7, right? That is y equals 2 times 5 minus 3 is 2, negative 2. That would be 8. You already have negative 2 here, right? So it would be 8. That means the equation is y equals negative 2 x plus 5 whole square, because axis of symmetry is 5, and plus 8. X minus 5, not plus. So you have to write the equation in standard form. Just multiply them. It would be negative 2 x square plus 25 minus 10x plus 8. So let's just multiply. Negative 2x square minus 50 minus plus 20x and plus 8, right? So just collect the like terms. Negative 2x square plus 20x and minus 42. So that is the equation in the standard form. Here is the equation in vertex form. And here is the axis of symmetry, that is x equals 5, right? Okay, we'll start with question number 5. For each quadratic relation, determine the coordinates of 2 points on the graph that are the same distance from the axis of symmetry. Determine the equation of axis of symmetry. Determine the coordinates of the vertex and write the relation in vertex form. Y equals x minus 1 and x plus 7. Y equals x minus 1, x plus 7. Okay, you can see the points are negative 7 and 0, 1, 0, right? These are the points that are equidistant from the axis of symmetry, right? You can calculate the axis of symmetry using these 2 points. It would be x equals negative 7 plus 1 over 2. That would be negative 3. That is the axis of symmetry, right? So when x equals negative 3, I'll just calculate y, right? It would be y equals negative 3 minus 1, negative 3 plus 7. That would be negative 4 and 4. That would be negative 16. That means the vertex is negative 3 and negative 16, right? So the equation would be y equals x plus 3 whole square and minus 16, right? Okay, the next one is question number 7. For each equation, each quadratic relation, use partial factoring to determine 2 points that are the same distance from the axis of symmetry. Determine the coordinates of the vertex. Express the relation in vertex form and sketch the graph. Question number 7. Y equals x square minus 6x plus 5. Okay, so you have to partially factor the equation, right? It would be x square minus 3x. No, 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 no. You cannot factor. You have to partially factor. How do we partially factor? From here, we can take common x. It would be x minus 6 and plus 5. That is the partially factor, right? You have now x equals 6 and x equals 0 when you equate it with 0, right? So the equation of axis of symmetry is 6 plus 0 over 2. That would be 3, right? So let's just calculate the vertex. Just put x equals 3 in the equation. It would be y equals 3 square minus 6 times 3 plus 5. 9 minus 6 times 3 is 18 and plus 5. 9 minus 18 is minus 9 plus 5. That would be negative 4. That means the vertex is 3 and negative 4. Right? So the equation would be y equals a is 1. It would be x minus 3 whole square. From here a is 1, right? X minus 3 is whole square and minus 4. Okay. Let's just start with question number 10. Determine the value of a and b in the relation y equals ax square plus bx plus 8 if the vertex is located at 1 and 7. Okay, let's just start with question number 10. Equation is y equals ax square plus bx plus 8 and the vertex is 1 and 7. Vertex is 1 and 7, so the equation would be y equals a x minus 1 whole square plus 7, right? The y-intercept is 8. This one is the y-intercept. That would be 8. Just use it. 8 equals a. You have to calculate the value of a. X is 0 minus 1 whole square because that is the y-intercept. So x is 0. So it would be 8 equals a plus 7. Move 7 other side. That would be 8 minus 7. So a equals 1. Right? So the original equation is y equals ax square plus bx plus 8. Right? That means y equals a is 1, x square plus bx plus 8. You can just use the vertex. A is 1, x is 1, y is 7. 7 equals 1 square plus b times 1 plus 8. So it would be 7 equals 1 plus b plus 8. That would be 7 equals 9 plus b. Then b equals 7 minus 9. That would be b equals minus 2. Right? So the a equals 1 in the question and b equals negative 2. Okay, let's just start with question number 14. Okay, the world production of gold from 1970 to 1990 can be modeled by G equals 1492 minus 76 G minus 76 T plus 5.2 T square, where G is the number of tons of gold and T is the number of years since 1970. Like T equals 0 for 1970 and T equals 1 for 1971. During the period when was the minimum amount of gold mined, what was the least amount of gold mined in 1 year, and how much gold was mined in 1985. Okay, the equation is G equals 1492 G equals 1492 minus 76T plus 5.2 T square, and I think that is 57.6. Yes, 76T plus 5.2 T square. Okay, you have to calculate the minimum amount of gold, right? So to calculate the minimum amount of gold, we have to calculate the vertex first, right? So let's just calculate the partial fact. By partial factoring, it would be G equals, from here you can take T common, so you are left with 5.2 T minus 76 and plus 1492. So that means T equals 0 and T equals 76 divided by 5.2, that would be 14.6. So axis of symmetry would be 14.6 over 2, that would be 7.3, right? So that means you have to add 1970 to 7.3, right? That means it is 1977.2, because the axis of symmetry is T equals 7.3, right? So you have to add, it would be 1970 plus 7.3, so that is 1977.3. So the equation of the axis of symmetry is T equals 7.3. Just put 7.3 in the equation to calculate the value of the gold mined at 7.3. So just put 7.3 in the equation, it would be G equals 1492 minus 76 times 7.3 and plus 5.2 times 7.3 square, right? So just calculate the values. Hold on, let me calculate. It would be 5.05, right? That means the minimum amount of gold mined was about 1215 tons, right? To determine the amount of gold mined in 1985, you have to do T equals 1985 minus 1970. That would be 15. Let's just solve this equation for 15, right? Replace the T with 15. So it would be G equals 1492 minus 76 times 15 plus 5.2 and 15 square. So when you evaluate, it would be when you evaluate it would be 1522. That means the in 1995 about 1522 tons of gold were mined, right? Okay, you can complete the lesson by yourself later today. So we are done with the lesson. You have to complete the questions I skipped. If you still of the lesson, you can contact any tutor on the Skype. They are available Monday to Friday, 5 to 9, right? So we're working on grade 10 math on the chapter applying quadratic models, and the lessons we have covered today are solving problems using quadratic relations and connecting standard and vertex form. So please make sure before the next session you can complete all the practice questions for the lessons we did today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. If you have any question, you can please ask.